With the evolution of many downlighters and spotlights in domestic dwellings, you're trying to reduce the number of cables at the light point itself. If we look at this circuit here, we've only got one cable entering this lighting point. If we were to have multiple points from the same switch, we'd come off here with another cable to other lighting points, meaning that you only have a maximum of 2 cables at any one, say, downlighter in an installation, making it easier to terminate for the electrician. In order to do that, we need to take the feed to the switch. In this case, from the consumer unit, I've taken my permanent line, neutral and CPC down to my switch, and I'm going to mimic a one-way switch to start with. And from the switch itself, we're taking a neutral, a switching line and CPC to the light fitting itself. We've got our RCD protection in the form of an RCCB, because we know that all domestic lighting circuits need additional protection by an RCD, rated at, and in this case 30 milliamps or less. So that bit's correct. However, my students will notice that we've got the AC waveform, and we're aware that we are not massive fans of AC RCDs. We've got our overcurrent protection device. It's B6, so it's rated at 6 amps, and it is a type B in this case for the domestic dwelling which we're simulating. It could be a C, it could be a D, but we've got a type B here. We could have used one of these, this being a miniature RCBO. So we've got both the overcurrent protection device of a circuit breaker and the additional protection offered by an RCD in one unit. Again, B6, type B, 6 amps, rated at 30 milliamps. So again, for additional protection, rated at 30 milliamps or less. And this time we do like this one because this is an A-type device, and we're looking to move towards more A-type devices, something we've talked about a lot in the classroom. So we're at the switch now. Subtle difference than all the other lighting circuits that we've actually wired at college is that we've now got 2 cables. We've got 2 twin CPCs here. We've got the feed coming in, so we've got a line, a neutral and a circuit protective conductor coming in this case from the consumer unit. And going out, we have a switching line, a CPC and another neutral. I know at some colleges where there is, say, one cable coming down to a switch of twin and CPC, often it is the blue is a switching line conductor and is identified with brown sleeving. In this case, where the feed has been taken to the switch, doing the 2-plate method, both the blue conductors are actually neutrals. Concentrate on connecting the CPCs. We've got an insulated box and an insulated switch, so we don't need a CPC. We need it if there was an exposed conductive part, a metallic light switch, etc. However, we're still going to need it as part of the circuit and further upstream, so we're going to connect them in the back of the actual switch itself. Remember, the rule for Gary is it's approximately about 70 mil longer than the box for all conductors. So if I cut those off at that point just there, and then we can over sleeve it. So we've got to put our green and yellow sleeving on. So I can measure the length approximately down to here. Fold it then in half, and we can cut those two to exactly the same length. There's one, and there's the other. We're still going to double over our terminations, so I'm still going to double them over to go into here. So take our CPC, might just trim it back a little bit, and I'm just going to double it over, a technique we've seen many times on the channel before. Take the other one, trim it back, and double it over. In and hold it. We've got our CPCs terminated into the back of the box. Just dress those out of the way. And this time we're going to use our Wago. This is a 3-conductor connector. We could have had a 2-conductor connector. I just couldn't find one for the video. So we've got a 3-conductor connector here. And on the side of it, as shown in previous videos, you can see that you've got to strip back to 11 mil the insulation off the conductors themselves. Lift up the levers. Insert our conductors in like so. And then just, there we go. So they're now connected. Double these over. Taking slightly less than half, folding it against itself, squeezing up the gap, taking slightly less than half, folding it over, squeezing it up against itself, get rid of that gap. So I've got 2 doubled over terminations. The switch I'm going to use is a one-way switch, common and L1. Doesn't really matter which way around they go, but I will put the incoming line conductor in common and the switching line in L1. So take the line conductor, and in we go like so. Just push it back into place. So as I'm holding it there, I'm going to hold it in place as I tighten it up. Like so. And then take my switching line and going to L1. Again, hold it into place as you tighten it up. So let's have a look then. So we've got our permanent line coming down into common. We've got a switching line going back out to our light fitting. We've got our two neutrals connected together in a Wago connector block, and our CPCs are secured in the back of the box because it's a fully insulated box and switch. I've used a conventional 3-plate one, so we've got the loop-in terminal in the center, which is no longer needed. We've got the switching line coming from the switch, the neutral coming from the switch, and the CPC also coming from the switch. So this cable here brought in the switching line, neutral and CPC, and is connected neutral across the lamp, switching line across the lamp, and the CPC secured in the back of the actual fitting itself. And we can see how this 2-plate method reduces the number of cables here at the lighting point. Very important when we're fitting downlighters, LED spotlights, etc., that we reduce the number of cables, and by using the 2-plate method, it means we've cut down the number of conductors. If we want another light to come on at the same time, the neutral, the switching line and CPC would loop round to the next light, to the next light, to the next light, meaning that we get a maximum of 2 cables per downlighter.